Hey, how's it going, everyone? It's Lee Halliday, and what we're going to be covering today is how to test your GraphQL queries using the Apollo library, but we're going to be using something called the AutoMock provider. So before we get into that, right here is the output from the code that we're going to be testing. So it's not much to look at, but it queries some data from the Shopify GraphQL API and displays it on the screen. In a previous video, if you're interested in checking that out, we use something called the mock provider, which comes from the Apollo library. So what you do is you import the mock provider, and you use this provider to wrap the component that you're trying to perform a query with. And by using this provider instead of your real one that you may have defined in some sort of Apollo client file, which imports all the different sort of HTTP links and context and error handling and all of that. By using the mocked provider and providing that provider to the products component, when it performs the query, it won't go out to the internet, but it will use some mocked queries instead. And whenever you use this, it's sort of a pain because you have to define an array of all of the possible queries that could be run. So you have an array with an object, and it's got the request. So when it sees a specific query with these specific variables, it's going to explicitly return this result. And it's great because it's easy to get up and going, and it's very sort of obvious what's happening here. But imagine you have to do this a ton of times, and maybe you've got 10 products you want to display in your test to make sure that it works when you have 10 for some reason. If you add a new field to your query within your component, so say you come in here and you add in price to this query, you have to go back and you have to add price to all of the different mocks so that it has that available. And that can get a little bit tedious. And there's another solution which instead of mocked provider, we'll call AutoMock provider. So I first saw this in a talk gave by Chang Wang at GraphQL Day in Toronto. And I'll link to his video in this video so you can check it out, because that's where I got a lot of the ideas from, and then I sort of researched how to implement it myself. And he does it sort of more talking about Storybook, but the principle's all the same. Whenever you're showing Storybook, you don't want it to perform the real queries. You want it to sort of have something reproducible, and tests are the same. You want them to be fast, reproducible, and the best way for that is by mocking in some way. And this is one of the ways you can mock that. So if we come back here, we've got this, it renders with mock provider. We're going to just get rid of all of this. And we'll stick with this sort of stub test for now. Except we'll switch this up to AutoMock provider. Okay, and we'll switch that. We'll remove the props that were being passed to it, and we'll start with this. So we have to go and define our AutoMock provider. And I've sort of stubbed that out in this file here. And the reason I stubbed it out is because it's impossible for me to memorize all this stuff. It'd take me like a week to remember this. So it's got a ton of imports, but the goal of this is basically to create a component that you can export, and this will act as your AutoMock provider. So it will receive children. That would be the products that we're passing in here, right here. And those are sort of React nodes. And then we can pass in some mock resolvers if we want to. And so we're going to walk through the 5 steps here to make this work. And the first step we need to do is basically take a JSON schema and convert that into the schema definition language. Okay, so JSON schemas, where do they come from? Whenever, or most of the time, whenever you have a GraphQL API, you can perform a special type of query called an Introspection Query. And what this does is it returns sort of a whole bunch of JSON with all of the data about the schema. So I've got this file here, schema.json. And this is literally the entire schema from this Shopify's store GraphQL API. And in it, it sort of defines every type, every field, the description for it, what type of data it is. So whatever this field is, it's an argument first. It's a scalar that's an int, and so it defines all of this data. So how did we even get this into our project? So we're not going to cover this here, but I'll link to the code so that you can sort of copy it and you'll have it for whatever GraphQL API you're working with. But Apollo CLI Tools comes with a command called schema download. So you can basically just take this command, point it to a GraphQL API, so the endpoint. If you need to pass additional headers, you can do that. And then by running this command, what it will do is, I think by default, it places it in this schema.json file. Now the problem is that the code we're writing doesn't want it as a JSON schema. It wants it in the schema definition language, which is like a GraphQL specific thing. And we need to then convert from one format into another. So what we'll do is we'll define a variable called schema definition language, schema DL, we'll call it. So we're going to use a couple functions. And the first function we're going to be using is called print schema. Like that. And what we're going to pass to this function is a call called build client schema. Okay. All right, so both of these come from the GraphQL/utilities library. And what we want to do is pass the schema into this. Believe it's actually underscore. There we go. Okay. So underscore schema. So the schema will be coming from this schema.json file. So introspection result. And if you go and look at this schema.json, it has underscore schema as well. So that's what we're going to be grabbing. And just so that it works with TypeScript, for this we have to just convert it to any so that it doesn't complain. Okay. So what this does is build client schema basically reads in a JSON schema and it returns, let's see, what does it return? Returns a GraphQL schema. And then what we want to do is basically pass that GraphQL schema to this print schema function that will return a string, which will be the schema definition language. So it's just converting from JSON into schema definition language. So the next thing we need to do is take this schema that we've just generated by converting it, and we need to make it executable. And what that means is basically it's we'll pass it in and it will create resolvers for each of the different fields that we can then tweak later on. So for example, if we were asking for products or the ID of a product node, it will have a resolver for that. And by default, it comes with a few nice resolvers like strings are always hello world, I believe. IDs are always UUIDs, but we'll get there in a sec. So what we want to do is we want to say const schema, and that is equal to make executable schema. Okay, and what we need to pass to this is an object that has some type defs. So these are just the type definitions for our GraphQL schema. So we'll take this that we just generated up here and pass that in. And then there's a couple options you need to pass, and I'll explain what that is in a second. So the resolver validation options, and then we want require resolvers for resolve type false. So the Shopify GraphQL schema, it comes with some non-standard sort of custom scalar types. So you've got your typical ones like strings and ints and booleans and stuff like that. Shopify has declared a few custom ones like URL. And if you don't pass this option in, you're required sort of by default to provide resolvers for all of these custom types. And eventually we're going to need to, but this gives us a little bit more flexibility. Okay, so now that we have this executable form of our GraphQL schema, we can call a function called apply mock resolvers. What is it? Oh, add mock functions to schema. Sorry. Okay. So for this, we need to pass in the schema that we generated before. And then this function, add mock functions to schema, is going to tweak it. So it will, this is not immutable, it's modifying the schema. And it's modifying it with some custom mock resolvers that we can pass in. So mock resolvers, oh sorry, I think it's, here are the mocks, and they are mock resolvers. Like this. So by default, it provides its own mock resolver for all of the different types in your GraphQL schema. So as I mentioned, anytime you ask for a field that is a string, it will return with hello world. Anytime there's an int, it will return with the same number sort of every time. Anytime you ask for an ID type, it will return UUID. But it will give us the ability to override these so that we can customize any resolver for our tests. And again, no need to say equals because it's actually modifying the schema that we pass in. So now that we've added mock functions to our schema, we need to define the Apollo client. So here we'll say client equals new Apollo client. And what we need to do is provide a link for this Apollo client. And the type of link we're going to be using is a schema link. So we'll say new schema link. And what we need to pass into it is the schema. And then we also need to provide a cache for this Apollo client. So it will just be a new in-memory cache, like that. And again, I'm going to link to the codebase for this so you can take a look at all of these imports and what library it comes from and maybe what version I've used by just checking out the package.json. But getting back to this code, so we've defined our Apollo client, which is using the schema link created by adding mock functions to an executable schema, which comes from the schema that's been converted from JSON into schema definition language. So the last thing to do is that we want to return the Apollo provider like this. We're going to embed the children that we receive here into it, and we have to give it the client. Every Apollo provider requires a client, which is this guy here. So now that we've gone through all that work of setting up a custom Apollo provider, which will give us mock functions for every query that we perform, let's go and try it out by writing some tests. So we've got this here, and it was the mocked provider that we were using that's provided by default by React Apollo. And we've changed that up to wrap our products query with our auto mock provider. So let's take a look and see what happens. We've got our test here. It's been running in the background and it fails. So it fails and displays on the screen error loading products. So let's go troubleshoot and figure out how to fix it. So if we go into our query, I'm going to just add some good old-fashioned console log of the error. So we can come back here and see what it's doing. Okay, so the error we got is that there's no mock defined for type URL. So as I mentioned, it comes with mocks for all of the predefined in the GraphQL schema language, like strings and ints and booleans and whatnot. But Shopify has some custom scalars, so we have to define a mock for that. So let's see how we do that. We would do that by coming into our test, and we can pass in our mock resolvers. So we can say mock resolvers. So what this is an object where for each different type, so in this case we're talking about a type of URL, we want to provide a function that returns a value to resolve to. So here we've got the URL, and let's just say we're going to return shopify.com. So every time you see a type of URL, this is the value I want to produce. So we'll pass this in, mock resolvers equals mock resolvers, like that. And we'll come back and we'll see what's up with our test. Okay, it's taking its time. All right. So it rendered this time, and you can see the output displayed on the screen. It's got hello world a couple times. And the reason it says hello world is because every time it sees a string, hello world is the string it resolves to. So if we want it to resolve to something else, we have to provide a mock resolver. So say, like in our previous test, we were looking to find the text snare boot. So we would come in here and we'd add another mock resolver. So what do we want? Well, if we come to the query, we're trying to tweak the title here. So it's a title of a node of edge of product. And I think the easiest way here to figure out sort of how to mock this is to go take a look using like an explorer like this. And you can hover, let's say, the node and see what it is. So this node is a type of product. So that's the thing that we want to mock. So we're going to mock a product. And then what we want to do is return a function, or give it a function that will return another object that will give us the ability to mock the title. So here we can return snare boot, like that. And then we come back to our test, and now it's passing. So we fixed it. Cool. All right, so there's going to inevitably be a bunch of resolvers that you always you don't want to have to do the URL every time. So what we could do is actually just cut that from here, and we could go into our auto mock provider, and maybe we define some default mocks. So default mocks, yep, and we'll place the URL in here. And then what we can do is just take our default mocks and then the mock resolvers and sort of merge them together. What did I do wrong? Two periods. There we go. So it's going to place in the default mocks, which then can always be overridden by the specific test's mock resolvers. So if we run this again, it's still passing. I think I left that console log in there that we will remove. Cool. Instead of sort of generating the same string every time in this case, we're going to look at an image. So in this case, it outputs an image here. So the image has a transformed src, and this is type URL. But let's say we didn't want it to just always be this shopify.com. We wanted it to be cat.jpg or cat.png or whatever. Well, with this specific query, we're actually passing in the type of content we want. So when we query it, we're saying, give me a JPEG. So how do you access this variable here within your custom resolver? So what we can do is we can put a comma and we will override the image type. So image has transformed src, like that, and it will be an arrow function that will, let's say, have some backticks, which will be shopify.com/cat dot and then JPEG or whatever we want. So here we want to embed the actual type that it is. So that actually gets passed into this arrow function here. And the first parameter that you receive, I'm not even sure because I've never used it. Let's see if we hover. No, it's not even telling us. That's okay though. We'll just say as any, because who knows. So the next one we're receiving in is, no, you do it like this, right? Cool. So the next one we're receiving, which we'll also just say as any so that we don't have to deal with TypeScript right now. these are all of the variables that you're receiving in. And the truth is, this one might be the query itself or your context or your parent. It's something along those lines, but I haven't needed it yet. So these are all the variables we're receiving. So if we go to our actual query, it's receiving the preferred content type. So we can come in here and then receive that. And then we can embed that in here. Okay, so now whenever you call transformed SRC, you are going to be, instead of just your normal URL, which is the type, we've overridden it, and the transformed SRC will return this string with the embedded value in there. And let's just see if it is working as we think. Let's just say, so that's the URL, and we want to return the URL. And we'll just console.log to make sure that it's actually calling it. Okay, there we go. All right, so we can see it's being called a bunch of times. And every time it's producing cat.uppercase JPG. So if we needed to switch that up, we could just say, what is it, to lowercase, like that. And now we're getting cat.jpg. Okay, so why did it return 4 cats? The reason is because anytime there's an array, it returns a number of them. And I forget exactly how many it returns. I'll just swap this back so that it's less code. Bear with me. Okay, there we go. So this returns this now. So let's see how many it's returning. And we'll do that with our good old friend console.log, and we'll stringify the data being passed. Okay, so we can see just, let's say, image edge. So we're seeing 4 image edges, and I believe what's happening is it's doing 2 products, each with 2 images. So that's how you come up with the 4. So if you want to customize that and say you just want 1 image to be returned instead of 2 of them, what we can do is we can come in here and our product asks for images, right? And what we can do is define a mock resolver. Sorry. We can define a mock resolver called images. And what it will return is a new mock list. Have I imported that? Yes. So this comes from GraphQL tools. And what it allows you to do is define how many images you want to receive. So we can say an array 5, 10. So this will give us between 5 and 10. So if I let this run now, it must be because I messed this up in some way. Oh, I think I know what it is. It is because this actually needs to turn in edges, and edges returns there we go. So images, we can confirm, it's working now, cool. So now you can see that there's a whole bunch of, there's between 5 and 10, and you actually get a different number because it's doing randomly. 5 this time and 10 the next time. So here's 6, here's whatever that is, 9 or something like that. Another thing we can do is we can just say we want always just one of them. So images resolves edges, and edges is the actual array, not images. That's where I messed up. So edges will return a mock list with 1 every time. Cool. And there we go. So we are just seeing image edge in here just 1 time. Great. Okay, so let's remove our console.log. Actually, we'll keep it for now. So the next thing we're going to do is we are going to write a snapshot test. So renders for snapshot with auto mocked provider. Okay, we'll do this async. Okay, so we're just going to copy this so that I don't have to rewrite it all. And for this, we don't need the custom image. We can get rid of that. And I actually don't think we need custom anything here yet. So we'll just declare this as an empty object. And what I want back from this render are find by test ID and as fragment. So we're going to use these two to help us with our snapshot test. So we don't need this one. Okay, so now that we've written this render and it returns us the find by test ID, and the reason this works is because in my products, I declared a test ID on this here, and I'll show you why we need this in a little sec. What we're going to do is we're going to await that it's able to find by test ID the result. So the reason we're doing this is because by default, this is asynchronous in nature, so the first time it renders this result, it will actually be the loading. So this loading products. We don't want to write a snapshot for loading products. We actually want to get this here. So by awaiting this div, by looking it up by this test ID, we're able to make sure that it's actually been rendered at this point. So then we can say expect as fragment to match snapshot, like that. Okay, so it's going to run, and it immediately failed. So why did it fail? It failed because every time we run this thing, it's generating unique IDs. So we don't want it to generate unique IDs because it's going to make every snapshot fail for us. So there's a little trick you can use. If you're using a faker type of library, so we're actually using one called faker here. Have I imported it? No. Okay, so we'll import it. Import faker from faker. Like that. So faker allows you to sort of produce fake data like addresses or numbers or IDs or stuff like that. But one of the cool things it provides is that you can say faker.seed. So by default, every time it's generating fake data, it's using a random seed so that every time you run it, you're getting different results. But in this case, we want a random result that's reproducible. So we can say faker.seed and we can pass in sort of any value, 1, 2, 3, it doesn't really matter. But now every time it runs, it's going to get the same random value every time. So that doesn't solve the problem yet because the IDs that are being produced by the mocked ID type right now are not using faker. So we can come in here and we can say we want to provide a custom resolver for the ID type, and what it will be is faker.random.uuid, like that. So I think it's going to be wrong once because of the previous seed, but what we can just do is, I think it's U, and that will regenerate the snapshot. And now every time, so I'm pressing A to run all tests again. So every time I run this, it's going to be using the same random ID, meaning our snapshots will always match. So if I remove this and just take a look at the snapshot, so it's always going to have this one here every time, which is pretty great. Okay, so all of the tests are passing. Let's just do a quick rehash of what we covered before my computer runs out of hard disk space. What we did, instead of using the mocked provider that comes with React Apollo, we created our own. So we called it the auto mock provider, and what we did is defined a functional component that takes in some children and optional mock resolvers. First step is we converted our JSON schema that we exported using the schema download command in the package JSON, and we converted it into schema definition language. So we passed that in, built it into a GraphQL schema, and then printed it back out in a schema definition language. We then took that schema that we generated there and we made it executable so that we can execute queries against that schema. So we passed in our types for this schema. So this field is a string, this field is an ID, etc. And we passed in this option. So we're not always required to provide custom resolvers for things like URLs. It may be a good thing if you want to do that. Say there's only a few custom scalar values. You can just provide them all. That's fine. And then what we did is we took this executable schema and we added mock functions to it. So this is where you get every time there's a string, it says hello world. And we passed in some additional mocks so that we can customize that. We've got our default ones, which provided the URL that we built. But then we added in the user sort of custom ones that are unique for every test. Once we have modified this schema, we created a client using the schema link, passing the schema in. And once we have the client, we can return our Apollo provider with this client. So that whole package gives us the auto mock provider. And what that allows us to do is to only when we need to provide resolvers for the different types or fields. So if everything is just, you don't care if it says hello world, you can just leave it as is and you don't really need to provide any mock resolvers, which is pretty great if you compare that against the mocked provider where you have to provide the entire result from the query. So here what we did is we overrode product, and you only need to override the fields that you need to. So we didn't touch ID here, for example. We overrode title, we overrode images, so that when it has the edges here, it's going to always return just one value in the array rather than many. And we also overrode image, transformed src, so that we could use the variable being passed into our query, helping us build a response for this resolver. So here we're just testing that some text is in the document. The point of this isn't to go deep into testing what the HTML is that the component is producing. For the purpose of this test, we're just showing how to mock out queries. Then we looked at how to take snapshots. And typically for snapshots, you're going to want to provide a seed to a faker library so that you can get consistent random results. So by overriding the ID type using the faker random UUID, we're going to get the same random values every time. And then we were able to make sure that it has actually rendered our query result. And we're expecting that the fragment that was rendered matches our snapshot, which is stored up here in the snapshots folder. Sorry for a longer video, but we covered a ton of content today. I will link to the talk that I mentioned and the repo in the comments below. Hope you liked it. Peace. Bye.